We're going to be talking about the average value integral today. You've been finding an average since middle school. How did you do it back in the old days? Well, you added up some values and then you divided by the number of things you've added up. Whenever you see a summation symbol in calculus, you should think it involves a definite integral. But see, this is not a Riemann sum, and so we're going to need to multiply by a form of 1. I'll use b minus a over b minus a, and then I'm going to interchange these two denominators using the commutative property of multiplication. Now I have a summation of f of x divided by b minus a times b minus a divided by n. You might recognize this as being delta x. So I now have a summation of f of x times delta x divided by b minus a. This is a Riemann sum. If I put it through the limit process, I can convert it to a definite integral from a to b of f of x dx, and then I'm dividing by b minus a. To understand this better, we can draw a figure. Here's the function f of x on the interval from a to b. Remember that this definite integral represents the area between your function and the x-axis on the interval from a to b. And we're dividing the area by the width, the distance between a and b. Well, if you divide area by width, you should be getting a height. But the question is, which height is it? Is it the tallest height? Is it the smallest height? Well, it's the average height. So this represents the average height, or the average f of x. So when I see an integral in this format, I should realize it represents the average value of a function. I like this format because I can really see the summation, that I'm adding things up, and then I'm doing a division. But most textbooks are going to show it in this form, where you have a coefficient, 1 over b minus a, integral from a to b of f of x dx. So I might see something like this: 1 over 3 integral from 2 to 5 c of t dt. And I would recognize that this represents the average value. This is the average value of c of t from t equals 2 to t equals 5. Let's look at a different example. If I were to see 1 over 4 integral from 1 to 5 of n prime of t dt, I would recognize that this is the average value of something. In this case, it's the average value of the derivative. One of the ways to think of a derivative is as a rate of change. So this expression that I have here represents the average rate of change. Remember, that's another word for derivative, of n of t from t equals 1 to t equals 5. You might be thinking, wait a second, there's another way of finding an average rate of change. If you recall, when you integrate a derivative, these two should be canceling each other out, because the integral is also an antiderivative. So if I do the antiderivative of the derivative, I should be back to n of t. So I'll have n of t, and then I'll evaluate it from 1 to 5 using the fundamental theorem of calculus. So I'll have n of 5 minus n of 1. And I could also write that as n of 5 minus n of 1 over 5 minus 1. You might recognize this difference quotient as being another way to find the average rate of change of n. Notice that this expression and this expression have the same interpretation. They both represent the average rate of change of n of t on the interval from 1 to 5. Thanks for listening and enjoy calculus.